Okay, so I wanted to go through the whole process that I use of creating a new model for the cross streets. We'll go to a new file, in model, we're going to name it model cross street, and the name of the street that we're doing, I believe we're on Schreiber. Yeah, Schreiber. Let's go back to there and Schreiber. Save. That'll open up a new empty workspace. This may take a moment. Alright, so we got a new empty workspace. We need to start adding some references. We're going to add the geometry and the existing terrain model. Coincident world for both. Zoom extents to see everything, and this, we need to set the existing as our active terrain model. That way when we go to view it in a 3D view, it'll be in 3D. If there's no 3D files or no active model, the 3D model doesn't work. It'll come out flat. But anyways, we want to copy over. So this is from the geometry file. It's just a line representing the alignment of Schreiber. But we can copy it into the current file and start manipulating it. We'll go to drawing, copy, just copy it in place. We can turn off that reference for now. We'll need it again in a moment. But this is just a regular line. There's no information associated with it. So we want to turn it into a ruled element. So we'll go to Geometry, Design Elements, create Civil Rule. And make sure we're using active feature definition. That'll change that. And when you click on it and reset, it'll set it with rules, which gives it, it associates the length and points with it. I did notice that the end of it didn't match the end of the actual where it should. It should be matching up here to the main lane center line. So we can move this. Make sure get to the right spot. And that's in the correct location now. We can turn that level off. We just need the center line level from geometry at the moment. But we have this. We're going to kind of create a boundary so that we don't have line work, traveling all the way up and out of in areas that we don't really need it. So we'll change our feature definition to miscellaneous and draft. We're going to do an offset of the center line, the entire element, for 150 feet. Mirror, yes. And we also need to create lines along the main lane profile or main lane model, and we'll do offset partial. We'll go 12 feet to get to the inside travel lane, point to point, no mirror. And then we'll offset that one to get to the outside travel lane, 36 feet because we have 3 12-foot lanes. Mirror is no this time. We also want to set the location of the tie-in. This has already been designed in GeoPack, so we have the information. We're just transferring the information to OpenRoads to create the model, to create the 3D model. So looks like we're tying back in at 1340. That sounds about right. And so we'll create a line, turn on Civil Accudraw, which allows us to do a station and offset. It's asking for a station and offset, but it doesn't have any reference, so you need to hit the letter O on your keyboard, and it'll ask you for what element you want to reference off of. So now we'll put in station 340, and we'll do an offset of 100, and do that again. 340, offset 100. Excuse me. All right, now we're starting to get some elements. We also want to get the outside, outside of pavement of the cross street that we're doing. Go back here and take a look at the typical. Should be on sheet 2. We'll look at Schreiber. Schreiber, 2 12-foot lanes. There's also the 2-foot offset, but that's built into the curb. We want the edge of the pavement, so do 12-foot offsets of the whole element. This is just a guideline. This is an actual edge of pavement. We'll put the edge of the pavement in a moment. Offset 12 feet. We do want a mirror. All right. Now let's start adding some profiles to these elements. We turn Civil Accudraw off. Profile creation. We'll start with profile from surface. This one. Reset, and then it asks to, if you hit reset again, it'll use the active terrain model. That's what we want since we're tying into the existing terrain. And start to finish. Click through. You'll notice we've got now a 3D element here. We also want to do it on these 2 elements, but we want to use a different model. The model was created specifically for doing this. It's Pavement Projection. What it is just the top of pavement projected out, I believe another 50 feet, just so that it encompasses all the proposed roadway, even if it had a turn lane. I don't see that here. Did I not attach it? There we go. Now you can actually, you don't need it in this view. We can turn it off in this view and it'll stay in the 3D view. We want to profile from surface. We can select both of these. And we'll go over here and select the surface. Make sure it's, let's see, make sure I'm selecting the right thing. Projected pavement. Now I can turn that off and it should show elements there. Looks like I only may have gotten one. Also like to use 4-view when I'm doing cross street models because there's so many things going on. We'll take a look at this one in profile. Created that one. Good, that's what we wanted. But I don't think it created this one. We'll do a cross-section view later if needed. Okay, it's there. Just having a hard time seeing it. Looks like, yeah, turn that off. All right, now we can start on the profile of the center line. We'll look at it in profile view. And we'll start with profile intersection point. We'll ask what element to show the intersection on. We want to see it on the center line. And then we want to see where on the profile these elements intersect. So these are reference points to make sure that we're tied in. I'll show you a little kind of why we want to do that in just a second. Change back our feature definition to the baseline and see how many points we have in here. Back to the profile. Driver has a low point and a high point. I'll just use that as a reference. Excuse me. So now we'll go into the vertical portion of geometry. Go to create profile by complex PI. Select the profile view. Enter the force point. Make sure you're using snaps here. And then we said we had a low point and a high point, and we'll tie back in. Make sure again we use that snap on that point. You'll know you have the snap. Click on it, it'll show that little icon. And what that does is if I decide that this needs to be somewhere else, at a 340, let's say we can end up changing it, it's going to go to 300. If I move this line, the tie-in line, it changes the point where it intersects and moves that point. And since this line is tied to that point, it moves that as well. That'll come in handy later on as we're refining the design, but right now we'll change it back to 340. And let's take a look at the profile. Like I said, we'd already designed this, so all we're doing is taking the information and putting it into a 3D model. So the station 1160, elevation of 735, 35, and then station 1300, and elevation 738, 41, 60, 220. All right, so we have this point. We click on it, and it gives us access here. So our station starts at 0. This station starts at 10, so there's 1,000 feet difference. So instead of 1160, we're going to put 160. Elevation 735, 35. And instead of 1300, we're going to put 300. Elevation 738, 41. Change the length of the curve, 10 to 20. What happens sometimes, especially in OpenRoads, if you can't have a point hit another point. So this can be to 1999, maybe not, maybe 219. Let's go 210 for right now. Oh, I know what's going on. There's a little curve here. Didn't mean to put that curve there. So we'll go to drawing, modify, delete vertex. What that'll do is it'll delete that curve from there, but it'll keep the VI. BPI, excuse me. And that should allow us to go back to maybe 220. Yeah, there we go. That was the problem. This one, we'll change it from 10 to 60. No, doesn't want that. That's kind of what I'm saying. There's got to be a small gap in between the VPT and the VPC. If not, it won't compute it, which is kind of a pain. We'll get real close. There's our profile. We'll set it as the active profile, and that'll create the 3D element in our 3D view. Now it's time to start creating the edge of pavement. We'll change our feature definition, pavement, road, edge of pavement. And I believe we have 50-foot radiuses. It'll come from here to here. Go to geometry, arcs, arc between elements, simple arc. From one element to the next. It's going to be 52.5 because the radius that we're measuring in what is already designed, which is 50 foot, is the back of curb, which is 2.5 feet away. So change that to 52.5. Let's do the same thing on the other side. And now we want to create the offset from here to the tie-in. Same thing on the other side. And turn this into a complex element. And turn this into a complex element. Now we can take our profile and project it out. Profile by slope from element onto these edge of pavements. This is going to be, once again, a reference or construction line. And save these two. Locate the reference element. And we're going to go down 2%. Click through and it created this one. And there's a representation of 2% from our center line. So we want to stay close to that as much as we can, but we do have limits that we have to tie to. So we want to show where we're going to tie to using profile intersection points. Show it on this alignment. What we want to show is where we're tying in at the beginning, where we're tying in at the end. Now, change our feature definition, and we will create our profile for the edge of pavement. Profile, change that, goes down, up, and then finally ties back in to tie-in point. This was 59. This was 220. Now that we've got these, we can take the VPI, move it around to where it's close to the 2% slope. It's not going to be perfect, but the closer you are, the better. Having a nice smooth contours when the 10's finally created. Alright, that'll do it. And we'll set that as our active, that element. We'll project that over to the other one. Project profile to element. We're going to project 2 here. No, sorry. Select element to project. We're going to project this one to this one. Now let's look at that in the profile view. This should be shown as a guideline. We'll change feature definition by set feature definition. Click reset. Alright, and we want our constraining points there, there. Got. We'll create our profile. Down. Could go up, but might as well. Well, yeah, let's go up here and tie back to the tie point. What do we? Oops. Set that feature definition. Okay, let's try that again. Set feature definition. There we go. This was 220. This was 59. Alright, now we'll set that as our active. It shows up over here. Now we're going to create kind of lines on top of these construction lines, so it may get a little confusing. But what we want to do is we want to do an offset partial, but the offset is going to be 0. We're going to do that on this line. Do it on this line. And what I'm doing is I'm creating the break lines to be used to create the 10. Now this is our center line, but we're only the profile actually goes out into the main line. We don't want to show that in our 10, so we'll do it from this line and there. Now you notice they didn't show up over here yet because they don't have a profile associated with them. So we'll go to profile, slope from element, do the one that we want to profile, from the reference, 0% slope, and they'll start popping up as I do these. One more. Alright, now go here, turn off everything except for the road, edge of pavement. Turn these guys off as well. Only thing we have in here are 3D elements of the edge of pavement and the center line. These will be our basis for creating the terrain. So we'll select all those elements, go to terrain, create from element, data point to select. We're going to do feature time for the break line, max triangle lengths for the edge method. We'll keep that at 2. And we've created a 3D model based on those. But you'll notice it's flat. So now we need to go into model detailing to add some things. When you first open OpenRoads, sometimes it won't load the correct templates. See, it's loading from my C drive. I want it to load from the project, which is 156. Select that one. All I want to do is open it. There's no need to keep it open. It just loaded that. So when I go over to model detail and I create surface template, it'll be looking in that project directory and not the C drive. Select, locate the terrain model. No, we're going to go concrete pavement with aggregate base. And you'll see when it's done, what it did was create thickness to the pavement. We have a pavement thickness and a subgrade. We need to add now the curb and side slopes. So we've got to apply linear template. I'm going to set the linear. I'm going to start with curb part left. Come in here. Turn off the 3D reference. Make it easier to see what's going on. Doing the left one first. And we'll start with the radius of return here. Go ahead and note the station where it ends. Make sure the orange or brown or whatever color that is on the correct side. Put yes. Change this to Schreiber. Curve return. This is the northeast curve return. So what that did was create a curb and gutter, and then a 17-foot buffer before we start our 4-to-1 slope back to the existing ground. We'll change this later, but basically we want this to match up with the main lane sidewalk and buffer, and that's why it's so large. I'm not doing the sidewalk around here, so I'm just leaving this area flat. I'm not modeling the curb ramps at this time, so just showing a flat area that the curb ramps can fit into should be enough. But let's go ahead and do the rest of the other curve return. We'll go to right. Beginning. And take note of that. We'll come back and do something to that later. And this is the southeast. Created our so now we need to create the curb going along the rest of the cross street. And so just create curb, 2-foot buffer, and then tie in. This is going to be the left side. We'll start here. Go to the end. Left. that. One more. And on the side, left to right. But you'll notice that I have that 17-foot buffer and then a 2-foot buffer, and they don't really match up right. They don't match up at all, in fact. So what we need to do is change that. We can use a parametric constraint. So we'll select the yellow boundary. Yellow is the, what's it called? Corridor. The purple is the template drop. They're both the same length, but if you click on this, you can get parametric constraint. We're going to change that right back buffer. We're going to begin, and we'll end at 83.95. Oh, try that again. 83.95. Change the right back buffer. It's going to start at 17. It's going to end at 2. What that does is that tapers that buffer from 17 to 2 so that everything ties in where it's supposed to now. To the other side. That was 80, 98. Twice now. 80, 98. Constraint is back buffer. We're going to go from negative 17 to negative 2. Oh, what's going on here? Negative 17, negative 2. Now everything's lining up. And we have a 3D model of our cross street. We'll add that with the 3D models of the main lanes and the side slopes, and everything will start to come together. But that's how I do the cross street model. I went through a lot of stuff, and if there's any question on what tool I'm using, why I'm using it, or how to use it, let me know so we can get it figured out. We can get everybody on the same page and keep moving forward. All right, thanks.